Estimate the number of users of Rajiv Chowk metro station in a day. Take a moment, think about the problem, and if anyone can put in the chat box how they want to solve this problem, please feel free. We'll take a couple of minutes to think about this problem. Just tell me a broad strategy whenever you come up with it. Any ideas? Fantastic. So there are a couple of types of answers I wanted to hear, and you folks have covered it. So one was looking at the metro lines, which are the lines that are here, which come there, and all that. One approach. Second approach, starting with a population and figuring out what percentage use public transport, what percentage use metro, and going down from there. These two solutions always come. That's why I was waiting for it. And I think the problem can be solved from both these angles. Okay. However, they're incredibly more difficult to solve compared to the approach that I will discuss. Okay. A, they will require you to make assumptions upfront, wherein those assumptions will drive the solution. Okay. So if you make even the smallest of mistake in the assumption, then that is going to be a problem. Okay. So that's why I don't use these two approaches. I would request you to try solving this with those approaches and see, compare the level of difficulty with that approach and the one I am discussing, so that we have a better appreciation of this approach. Okay, do that at your free time. Now, one of your friends on the private chat has given me the answer, and why I am particularly happy is because she had seen one of my videos on a different case, and she basically used that solution, used that mindset to solve this problem, which gives me a lot of confidence that if you have solved one kind of such problem, clearly you can solve other kind of such problems also. So thanks a lot for that confidence. So it's a very, very simple problem to solve for. But first we will go to a point that Tanmay Betrabet has mentioned, which is when you have the users mentioned, let's first bifurcate the users into three parts. That there are three types of users. There are users who enter the Rajiv Chowk metro station. Okay. There are people who use it as a transit point, and then there are people who get off at Rajiv Chowk metro station. Which one are we computing, or are we computing all of them? That becomes an important question. Now, in this case, we are going to be computing all three. Or let's say the interviewer says that, user means all three, let's look at all three. That is a problem. Because when you have multiple problems, not all of the problems are equally difficult to solve for. Okay. In this case, the transit problem is a far more difficult one to solve for. The exit problem, I don't even know how to solve for. But the entry problem, I can solve. So typically what you do is you solve the easiest problem first, and then you leave the second and third. In most cases, you will find that the case interviewer does not even go to the second or third, or at least they will just ask you briefly what your strategy is. In that case, even if you don't have a very optimal strategy to estimate those, that's completely fine. I have never seen a case interview where all the parts of the problem are given equal weightage. They just want to check your thought process with one of the problems, and that's completely fine. By the way, this smartness to figure out that let's solve only one of the problems is also an interesting thing to have. It's good level of smartness. Okay, so let's look at all three. In, transit, out. Now, one thing I can, let's say if I have to do the out thing, one thing I can do is, one twist I can do is that Rajiv Chowk metro station specifically is not a residential area, right? There are not a lot of houses around the metro station, and the houses which are there are closer to some of the other metro stations. So for the purpose of this case, I can assume that it really at the very core of it is a transit station. So I can assume that the number of people essentially getting in and getting out would roughly be similar. Maybe there's a 5-10% gap, but that's completely fine in a guesstimate if you're off by 5 to 10%. The logic is more important. So I will just say, okay, fine, whatever is the input, I'm going to assume that's the output. And I've already stated a reason for that, which kind of makes sense within the 5 to 10% error magnitude. If you are uncomfortable making such statements, then you really have to start building a high degree of comfort on it. Because as the name suggests, these are guesstimates. There is a guess part of it and an estimation part of it. So you cannot seek exactness in this situation. You have to be more comfortable with the level of uncertainty that these cases have and just take blind leaps. Now, one important question that has come up is, what do we do if we don't know much about Delhi or Rajiv Chowk? Very, very good question. You ask, okay? You just say, hey, I'm not aware of this. More often than not, it's a pretty useful thing because one of the two things will happen. A, either the interviewer will ask you, okay, which city are you more comfortable with? And give you a problem for that city. Or they will give you a lot of information about Rajiv Chowk metro station and Delhi. The latter is super useful because they will only give you relevant information. So you are actually in a much better position compared to someone who has lived in Delhi all their life, because their mind would be crowded with hundreds of different facts, whereas you only have to focus on the 5 or 6 different things that the interviewer might tell you about the Rajiv Chowk metro station or Delhi. Okay, so don't be worried if you don't know the context of the problem, but you absolutely have to spell it out upfront that, hey, I don't know anything about Rajiv Chowk metro station. Please tell me more. Okay, I hope that answers the question. So this was asked to me by one of the people on the chat. Okay. So get used to input is equal to output. Transit, I'll say I'll deal with later. Now, how do we think about inputs? People who are doing it with a population approach, let me ask you this question. If tomorrow the whole of Delhi decides to use, let's say we all go mad and we say that we will take the metro today and all of us will board the metro station at Rajiv Chowk, all 2 crore inhabitants of Delhi. Is that going to be possible? The short answer and the only answer is no, because there are capacity constraints. That's why I don't like the population approach. Because with the population approach, you have to assume a percentage of people who are using public transport. What if that changes? My station can only accommodate so many number of people. So the population's behavior is only one aspect of it. I have to look at the physical constraint of what I'm working with. And this is what I'm going to work with in all such cases like these, which are figure out the constraints of what I have. Rajiv Chowk metro station can only and only accommodate a fixed number of people at its entry points. I'm going to estimate that number. And now, even if 10 times, 20 times, 50 times that number are going to try to enter Rajiv Chowk from that metro station, are going to enter Rajiv Chowk, they cannot do it. So I have an upper cap on my number of users. I will try to estimate that and then use fractions and use it. Okay, so let's go ahead with that. Okay. So someone has asked this question. Now I want to spend some time here because I want you to get convinced that why we are doing this. So a question has come up, and folks, I will really request you to put the questions for everyone so that others can also realize this is a question. It's just better that way instead of privately messaging me. So someone has asked, given the income inequality and many other factors, why is the population capacity aspect a dangerous assumption? I'm saying it's not a very useful assumption. Okay, you will still come to an answer, by the way, from this. Okay, it's just a much more tedious way of solving this problem, and the answer is unstable, because what if behaviors change tomorrow without the metro station changing itself? And here you have an easier income inequality aspect to it. But is that really the case that only low income students travel? DU students, even people who are fairly affluent, travel by the metro. A lot of environmentally friendly, environmentally conscious people travel by the metro. Office goers travel by the metro who live far away, just because they cannot spend like 1,500 bucks on cab every day, so they just prefer to use the Rajiv Chowk metro station. The income inequality does not directly map out to the usage of a metro. Okay, even if it did, it's a tedious approach. Okay, we just see how simple the other constraint-based approach is. Okay, so now someone had said that we will look at, is it a weekday or a weekend? Brilliant question. So before we again solve such problems, what I have to do is I have to assume some things about the situation I'm working with, because I know behaviors change. Okay. Now, instead of asking, do you want me to do this over a weekday or a weekend? Do you want me to do this over Diwali, just before Diwali, or any kind of variation day? I try to simplify my life and say, okay, can I just assume that it's an average day? There is nothing special about the day I'm working with. Okay. And if it suits you better, let's say it's an average Monday or an average Tuesday. The word usage average kind of gives you an escape. If someone tells you, okay, fine, why did you not consider that? Well, I think it was all averaged out. Okay. So do not try to include specifics or special cases in your analysis. As far as possible, rather state that you would want to use a very normal average case while solving this case. So let's say we are solving it for an average weekday. Now, there are a bunch of other questions also you can ask. Okay? So maybe a couple of questions that you initially ask, and then we jump to the problem. The problem now is very, very simple. Okay. Now, all I am doing is estimating how many people can actually enter the station and I'm sorted. Now, one thing we have not considered, and the people who are using the approach of what do we call it? How many trains come in and how many trains go? When I say users, it does not just mean passengers, right? There are a very small fraction of people like ticket collectors, support staff, cleaning staff, security guards, all of them who use Rajiv Chowk metro station. It's a good idea to mention that these people exist and ignore them, because 80-20. You will spend far too much time estimating probably what is going to amount to like 100, 150 people compared to about 50,000 or 1 lakh or 2 lakh people that use it for commute. So you can say that other than commuters, there are other types of people also who use this metro station, but they're going to ignore them as they're going to be very small compared to the commuters. Okay. So at all points, so I know a lot of you would be thinking, we can ignore that upfront, but state and then ignore that you have thought about this. It's not an oversight of a thinking process. It's a conscious decision because you are a smart problem solver that you're ignoring the smaller aspect. Okay. Now our problem is computing the number of people. Very simply done. The metro station works for few hours in a day. Okay. So let's say metro operates for 20 hours in a day. Again, I have no clue how many hours it does. My sense is it's not working from midnight to 4 a.m. This could have been 18, this could have been 16, this could have been 22. Doesn't matter. A lot of people get stuck up on these numbers, don't. Because these are just multiplicative factors. You're not expected to know these things. Obviously, if someone said 24 or someone said 10, that's a problem. 10 is a big problem. 24 is a small problem because that means that you are not being practical. But if you say anything else in this range, that means yeah, you are fairly practical and you know what is happening. Okay. Any of these numbers is okay. You just have to get a buy-in. You have to get approval of the interviewer. Let's work with 20. Now for all such problems, what I will do is I will assume that this 20 is broken down into 3 parts. It's always 3 parts. It's high, it's medium, it's low. High usage, medium usage, low usage. Okay. In this, the high usage is the most critical one. High usage is what I'm saying is where my demand matches my capacity, where my system is utilized to its fullest, not a single extra person could have entered. It's very easy to estimate this because once I estimate the capacity, which is a physical constraint, I will know how many people are using it also because there's a equality equation. Capacity calculated, I know how many people are using it, as simple as that. That's how I'm defining my high, when my capacity is fully utilized. Medium would be when demand is lower than capacity. And low is when demand is much, much, much lower than capacity. Okay. Now again, we will take a bunch of assumptions. We can assume that in the 20 hours that the metro line operates, 4 hours are high, 10 hours are medium, 6 hours are low. How do I define medium and low? Let us say I define medium as 0.5 of high and low as 0.25 of high. Where am I getting these numbers from? Well, I have a justification for high, why I have included 4 hours. So I can say that morning 2 hours when there is office rush and let us say evening 2 hours, when the people who work in Rajiv Chowk, when they are going back, okay, when there is office rush again, so 4 hours in a day, people are thronging to the station, people are trying to enter it. So 4 hours, things are definitely going to be hectic. So my demand is going to be matched to capacity. This could have been 5 hours, 6 hours, 7 hours, 2 hours. You just need to have some logic for it. You discuss with the interviewer and you come up with a number. So don't, I know a lot of people get uncomfortable with the numbers. Don't. It's a guesstimate. Have one reason, and whether you take 4 or 2 or 6 doesn't matter. If you had taken 12, that's a problem. Okay, that means you are not realizing the specifics of the situation. Now I've taken 10 hours and 6 hours and 0.5 and 0.25. You could have made this 0.5 into 0.7, 0.4, 0.6, anything. 0.25 could have been 0.1, 0.3, 0.2, whatever. Doesn't matter. Because these are two things which change together. The amount of time you are using and the fraction you are using. I am just assuming that from my experience, typically 10 hours in the day, only 0.5 people use it. It's only 50% of the capacity. You could say that, okay, if I want to change this fraction into 0.6, then I'll probably reduce 10 to 8 hours. Okay, so I hope you see, as you move up and down, the fraction of capacity being utilized, the number of hours will also change. So given both of these variables are for you to assume, whatever you assume, as long as it sounds okay, it's completely fine. So I always use 1.5, 0.25 for the sake of simplicity. And here I just, my rule of thumb is I get the high perfectly right. I give the maximum. Typically, I use 50% of the time for the medium, and then whatever is left, I give it to low. So after the 20 hours, I've given 10 to medium. I got this as 4, and then whatever was remaining, 6, I've put at low. Do whatever you have to do with it. Okay, don't get fixated. That's the main idea. So perfect. Here we are. Now all we have to do is estimate this missing number. Once we get this number, everything else falls in place. Now, the capacity constraint we are going to use, you have to now think from the point of a customer. Okay, what is that one point in the journey where you always have to wait, where you feel that the capacity constraint is always achieved? That's typically when you try to enter something, right? People who are not comfortable with metros, take the example of a theater. The bottleneck, you have to identify where the bottleneck is. The bottleneck is typically at always a gate. And here, in the case of a metro, the bottleneck is a security guard. Come what may, the security guard has to take, let's say, 3 seconds for every person to tap that down. They cannot make it 1 second. Obviously, they can make it 30 seconds if there are not enough people coming in, but they cannot move faster than 3 seconds. Now, again, whether it is 3 seconds, 4 seconds, 5 seconds, doesn't matter. You discuss with the interviewer and they give you an answer. I am assuming 3 seconds. That means a security guard at a station can at max allow only and only 1200 people to go through in an hour. Even if 20,000 people wanted to enter, this security guard can only allow 1200 people. So now, very simply, total number of people per hour in peak hours or in high would be total number of guards into number of people per guard. It's just as simple as that. How do we know the total number of guards? We know that Rajiv Chowk has many gates. So let's say that you can assume that there are 10 gates. At every gate, there is a guard. There are 2 guards, let us say. So you have 20 guards manning, and you just multiply that by 1200. So I have 20 guards into 1200, I get 24,000 people. So during peak hours of the day, all the guards put together, so 20 guards put together, can overall only allow 24,000 people to enter. Now, I have assumed 2 into 10, that 10 gates and 2 guards per gate. Okay. Now, someone might point it out that I have forgotten to include the female line. Okay. You could just say that, okay, fine, I'll make this 3 and I'll assume that the female guards also have the same pattern. While they don't, maybe there the peak hours are lower and the fractions change slightly. You can do a separate calculation for them with different numbers, or you can just include them here. It doesn't matter. You can say, I know female guards have a different behavior. There the numbers will be different. For the sake of simplicity, I will just make it 3 here. Okay. So this becomes 30. Once you say all of these things, whether you do these calculations or not, it doesn't matter, because these calculations are so easy that they don't care. Okay. Now my entire problem is solved. Per hour, per overall, 36,000 people can enter during high hours. That means during medium hours, 18,000 people. So 36,000 into 0.5, 18,000 people enter. During low hours, 9,000 people enter. 36,000 into 0.5. I multiply 36,000 by 4, I get 1,44,000. I multiply 18,000 by 10, I get 1,80,000. I multiply 9,000 by 6, I get 54,000. $378,000. I did all this math here. Do you think this was required? Answer is no. Instead of writing 144, I could have just written 150,000. I could have written 2 lakh and I could have written 50,000. 1.5 lakh plus 2 lakh plus 5,000, I could have just said 4 lakh instead of 3,78,000. This is how you simplify the math. Okay. No one cares whether the numbers are exact or not, because you have made so many assumptions already. It just doesn't matter whether you round up by 5-10%, whether you round down by 5-10%, right? So instead of 36,000, I would have made this 40,000. I would have made 18,000 into 20,000. I would have made 9,000 into 10,000. And my calculations would have become easier just like that. Okay. That's why you don't need to worry about math so much, because you don't have to work with exact numbers. Just round them up, round them down, whatever looks like a good rounded off number, just work with that. Okay. So I hope this gives you some confidence about being able to handle math, and gives a very good idea of how to solve these constraints. Now on my YouTube page, I have a very similar problem of number of flights that take up from Delhi. I will solve that problem in exactly the same way. I will take the number of hours, I will make it high, medium, low, and I will figure out what is my bottleneck. In that case, you have to estimate the number of flights going out of Delhi. My bottleneck will be a runway. That a flight has to spend a minimum amount of time in the runway. I cannot have a flight going faster than, let's say, every 3 minutes or every 5 minutes or every 10 minutes. You get that number, let's say the answer is 5 minutes. So per runway, in the peak hour, only 12 flights can go out. Okay. Then I just take the number of peak hours, the number of medium hours, the number of low hours. I assign 0.5, 0.25, and everything is exactly the same. So this concept is applicable to so many different examples. Let me take another example. If you have to estimate the number of, how do I put it? Let's say any restaurant, let's say McDonald's, the number of orders that McDonald's serves in a day. You could go it from the demand side. okay, how many people order from McDonald's and all that, yeah. Or you could do it from the counter constraint. Okay, that what I will do is, let's say they have 3 counters. During peak hours, medium hours, low hours, I'll estimate. During peak hours, my assumption is that all counters are as busy as they can be. So every counter, let's say, takes about a minute to serve an order. So every counter can only serve 60 orders in 1 hour. That means across 3 counters, I can serve 180 orders per hour. Now I'll ascribe number of hours to high, medium, and low, zero point 0.5 and 0.25, and I get an answer of how many orders a McDonald's can serve in a day. So with this one approach, we've already solved 3 different cases.